Okay. Okay. Let's consider NH3. Okay. Nitrogen in NH3 is sp3 hybridized and it has a lone pair. Nitrogen has a lone pair. Okay. So, what's the dipole moment? Upward. Got it? The dipole moment is normally upward, right? Upward, 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 upward. So totally all dipole moments are upward. Okay. And what about water? Same, right? Right? What about the resonant dipole moment of these two OH group? Upward. And these two lone pair? Upward. So, upward. Right? How many hydrogen bond will be around NH3? How many hydrogen bond will be around this NH3? Okay? Okay. There's one lone pair. So, it will form another hydrogen bond. Shut up. Another hydrogen bond. Okay, let's do it like this. Shut up. One hydrogen bond. This lone pair form one hydrogen bond. Okay, what about here? There are two lone pair. So they form two hydrogen bonds. Right? Two lone pair, they form two hydrogen bonds. Right? H. H. And can you tell me how many hydrogen atoms are there around oxygen? How many hydrogen atoms? 1, 2, 3, 4. Totally 4 hydrogen atoms. And out of those 4, 2 hydrogen atoms are covalently bonded and remaining 2 are hydrogen bonded. Right? Hydrogen bonded, hydrogen bonding. Okay? Likewise, 4 hydrogen atoms around nitrogen in NH3 and 3 are covalent bonded and 1 is hydrogen bonded. Right? What's the shape? Around oxygen there are 4 hydrogen. So what's the arrangement of those 4 hydrogen? Shape? Yeah, it's tetrahedral. And here 4 hydrogen, it's tetrahedral. Okay, tetrahedral. Just use specifically. Nothing else, right? Tetrahedral. Okay, but what's the difference? This bond length is very much shorter and this bond length very much longer because this is secondary attraction. It will be very weak compared to this. Secondary attractions are very weak compared to this. Very weak. Compared to secondary, compared between secondary attraction, hydrogen bond will be strong. But when it compared with primary interaction, it will be very weak. right? Very good. Right? So arrangement of all four hydrogen is tetrahedral, and here it is also tetrahedral. Right? Okay, let's have a look at HF. Around fluorine, how many lone pair? Right? How many lone pair? Yeah, there will be 4 lone pair. Sorry, 3 lone pairs and 1. Okay, and how many hydrogen bond can form? How many hydrogen bond will be formed around fluorine? Not 4 hydrogen bond, only 1 hydrogen bond. Right? Here, 1 lone pair, so 1 hydrogen bond. 2 lone pair, so 2 hydrogen bond. But there, how many lone pair? 3 lone pair, but not 3. Only 1 hydrogen bond will start later. Right? We'll see later the reason. Right? Okay. So H. What is the shape? Around fluorine, how many hydrogen? 2 hydrogen. Yeah, 2 hydrogen. What is the shape? Angular. Just use the Whisper theory. Right? Okay, and another important thing, this type of regular or orderly arranged hydrogen bond can be seen only in solid state, not in liquid state or gaseous state. Right? Okay, only in solid state. Okay. Tetrahedral, only in solid, ammonia solid. Only in, normally ammonia is gas, and you should cool it to liquid, not to liquid, to ice. To solid, and you cannot see these type of orderly arranged hydrogen bond in water, liquid water, only in ice. You can find this in only in HF solid HF, not in liquid or gases. Why? Why you can't see this orderly arrangement or regular arrangement only in solid? Because solid particles are immobile. Liquid particles and gaseous particles are mobile. So you can't. This molecule is mobile. These molecules, all molecules are continuously moving. So how can you see this? You can't see this. This or regular arrangement you cannot see in liquid or gas, only in solid. Okay, only in solid. Got it? Okay. Is it enough? No. That's it. And what? Hydrogen. This fluorine is bonded to hydrogen, bonded to hydrogen, and this hydrogen will be hydrogen bonded to fluorine. What's the shape? Angular. And what's this shape? Around fluorine, 2 hydrogen. Around hydrogen, 2 fluorine, right? 2 fluorine. 1, 2. What's the shape? Linear. Use Whisper theory, right? Linear. Why? How many pairs? How many pairs are there around hydrogen? 2 Whisper pairs. 1 and 2. This should be considered as bond, sigma bond, right? This should be considered as sigma bond. So what? Linear, right? Okay. So hydrogen HF, short of. This is the way you should draw solid HF, right? But proper way is, see, HF. This fluorine will be hydrogen bonded to hydrogen. Right? This bond should be shorter and this bond should be longer. Why? Very weak bond, hydrogen bond, very weak. This is very strong, so it should be shorter, it should be larger. Right? This is the correct way. Like this. So linear, this should be linear. Okay? Yes.
Sorry, electricity.
HF, sorry?
Electricity.
No. Now solid will conduct electricity except metal. No solid will conduct electricity except metal. Only metal conduct electricity in solid state. Right? In room temperature. Right? Sometimes there are some semiconductors, silicon, germanium, they have a low conductivity, considerable low conductivity. Right? Apart from that, only metal conduct electricity. Right? Okay, and draw this on a separate piece of paper and write down solid ammonia. Ice, solid HF. Okay, solid HF. Okay, draw this.